relative to pumps. So when it comes to pumps, Belzona materials that are going to be involved, we're going to have 100% solid epoxy Novalax. That's what we're known for, is just high grade epoxies. And because we make them with the best raw materials, they're excellent when it comes to chemical resistance versus hydrocarbons, solvents, acids, sour water, and more. We have a lot of chemical resistance testing, a lot of case histories, so we can find if our material will be compatible with whatever's running through your pump. We have ceramic filled epoxies. That's gonna give them enhanced erosion resistance. You can't just put a regular paint into a pump. I mean, when you take out a pump out of service and you see what it does to the metal with the erosion and the pitting, you need something that has good resistance to erosion and wear. So we have our ceramic filled, and then we have our carbide filled. So the carbide filled, and we have an example, is going to be more when you have solids or a slurry type application, where you have rocks or sand, something really aggressive eating up your metal. And then in general, whenever we talk about rebuild products or paste grade products, we're talking about thick products that are used for pit filling, metal repair, or metal rebuild. These have a sort of like peanut butter consistency, and you can fill in real bad pitting or metal loss. And then we have our fluid grade products, which are our coatings, which are used to coat the actual metal. And we'll go into all that stuff. So if you're not familiar with how epoxies are applied, it is a very specific application that has to be done correctly, especially for applications like pumps, which are, I mean, you got a lot of flow, fluid velocity, erosion. You don't want to mess up any part of your application. So that's why we have specific guidelines, and we also know what we're doing. And we do a lot of these at our shop, and we also do trainings to teach people how to do it correctly. So before you get started, your asset or your pump, whatever your coating is going to be, you're going to have it. You're going to want to check it for salts and do kind of a preliminary check before you start blasting. So all of our coatings for immersion, you have to check for salt content in the metal, and it has to be below a certain threshold. If it's high, then you just desalt it with either a chlorid solution or a deionized water. So you don't want any salts on the substrate. Can lead to blistering of coatings. Once you got that all checked off, you're going to do your abrasive blasting, which is what you see in this picture here. That's going to clean off all the rust, take off any sort of mill scale rust or anything, and it's also going to clean your metal and give a rough anchor profile. That rough anchor profile is going to give us the adhesion that we're looking for. Once you're done with your blasting, your next phase is going to be, if you have pitting, you're going to do your pit fill, or if you have metal loss on veins, you're going to do that rebuild first. I have some pictures of that and some slides later. Once you're done with that, this is what we call a stripe coat. So any sharp edges, pretty much sharp edges or corners or welds, they get an additional coat. That way they have good coverage across the edge. Because the edge is usually the part that has, it's toughest to have that retention at the edge because it has a lot of surface tension. So that's our stripe coat. Then you apply a coat to the whole substrate, and then you do a second coat. Once you do a second coat, come back the next day, you have to do a full inspection where you test for coating thickness. The coating thickness has to be within the spec, and then you have to look for any misses, and that can be done with a spark test or a wet sponge test. So there's a lot to doing an application. It's not just throw it on. You have to, from start to finish, there's certain steps that have to be followed. And we try to do that correctly. And the biggest thing whenever you're doing one of these jobs is just document everything with QA, QC. That way you know what steps we're taking. So we're going to kind of limit this presentation to centrifugal pumps. And we're going to talk about rebuilding, reforming, casing repair, internal linings, and pump base applications. It's a pretty big pump here. So rebuilding. We get a lot of pump casings at the shop. Split case pump here with the cut water. has really taken a hit, as you can see here. So this is a situation where you can use our rebuild materials together with either a piece of metal, you can use expanded metal, or sometimes we use our reinforcement sheets. We have either polyester, carbon fiber, or fiberglass. Kind of depends on the situation. But basically what we like to call it is a little staple. So we would, for this scenario, you would kind of rebuild it with some paste grade and then put several layers of wetted out reinforcement as like a staple until you build it back up to this. For this actual application, we used a metal, kind of expanded metal that you could bend, and then that's what we used in this scenario. So once you do your pit fill and your rebuild, then you would give it a coat with a epoxy coating that can handle the erosion and the corrosion over time. This is a very typical, we get these impellers a lot at the shop. As you can see here, the vanes are quite beat up. These are a little bit worse on top. The ones on the bottom is a lot of times that's what we'll see, where they just have a pretty good pitting. I mean, almost like through wall, through the vanes, and just pretty bad pitting at the welds. So what we'll do is we'll fill in all that with the paste grade material. It's a 100% solid. I mean, when it dries, it's kind of like metal, and you do little staples on all the edges before. So this is an example of after the rebuild. So you can see the vanes are completely destroyed, and after you got your vanes back. And then, if it's a real bad scenario like this one, you might have to do a couple tries, like do one, let it dry up, and then build it a little more, and then kind of sand it down. That's all part of the process. And then once you do your rebuild, you put on your erosion resistant coating. Another thing that we use with our rebuild, so our materials can also be machined down. So for example, for shafts, so a lot of pump scenarios where it might be hard to do a weld, like a weld build up or anything like that. You can use our products to build it up and then machine it back down. This works for pumps, and I have some examples in the next slide where we use it on, or it's in this slide for wear ring seats and bearing housing. So you can do the build up and machine down method. Another good method for shafts, especially ones on site that you can't take off and take to a machine shop, is you can use a forming technique where you fabricate a former that's machined perfectly to the shaft. You apply release agent on the former. You fill in the void area with Belzona, and then you squish it down with the former. When you take off the former, your Belzona is perfectly, not machined down, but perfectly fit to that shaft. So this is an application at our shop where we use the wear rings to rebuild the wear ring seats. And we do a lot of applications for the bearing housing. You get some static, water in there, and you have some pitting, and you kind of lose your seal. And so we can rebuild that, and it can be machined down at a pump shop after. So we do that as well a lot. So a lot, and those come quite a bit where it's just difficult to do the typical repair. So they ask Belzona to build it up. Normally we build it up to about an 1/8 to 1/4 inch thick, and then they machine it back down to the proper clearance. So this is a casing repair. This was recently. This was a pump casing that handled rocks. It was like a slurry with rocks and sand, and they had a groove here right where the impeller sat. They said a kind of rocks would get in there and kind of groove out the metal. So this is not supposed to be like this. This is a scenario where you got a high alloy, nickel alloy casing, so it's taking a hit. So you need something that's pretty abrasive, resistant to abrasion and erosion. So this is where we went with our carbide filled products over our ceramic filled products. So this is actually one of the grooves one of the worst ones. So we filled it in. This is, I would call this a paste grade product. It's carbide filled. It's used a lot in mining for heavy abrasion. And so we used it as a rebuild and a coating for this scenario. So instead of doing the typical paste grade and then coat with ceramic filled coating, we just did both with this product, as you can see. And that, it took a little bit of time. You fill in the groove first and then kind of pack it down. This is not a product that you want to machine down, so we had to be very careful to apply it as, good as we could to not mess up any clearances. This is a kind of external repair. They had a crack on the flange, and they used one of our composite materials, Belzona Super Wrap 2, to kind of seal in. It was leaking, had a crack here and along the flange. So they were able to use this carbon fiber to do an external wrap to hold in the pressure, hold in the leakage. This is another one that had a through wall right here at the pump outlet on the casing. So they filled it in with our paste grade material. It was filled in, the hole was filled in. We also put some composite reinforcement sheets over the hole, kind of like a rebar and concrete type of deal. So we have reinforcement sheets that we put over holes, build it up, smooth it out, and then 2 coats of your epoxy. So it can be used to fix scenarios that are kind of, you think it's beyond being fixed, we can go in there and fix it correctly. And then those are kind of more repairs going into internal linings. That's where we come with our ceramic filled fluid grade products. So this is Belzona 1341. We use it a lot for impellers. It is shown to increase efficiency, and we'll have a slide on that later. But as you can see, it's a smooth coating, fluid grade coating that is used to reduce erosion and corrosion within pumps. So we used it in some suction bells for some river water. And then this is the case history for the efficiency testing that was done. So they had a cast iron casing with a 3/16 stainless steel impeller. Both the casing and the impeller were coated with Belzona 1341. And it just showed a 9% reduction in electrical consumption. And this would be, the reason for this would be the surface roughness of the coating. It's very smooth coating, so you're just reducing friction within your pump. And then also, over time, you're not dealing with corrosion that could reduce your pump efficiency as well. So over time, it's probably that reduction in electrical consumption is going to be even better. I actually went to go see a pump that was coated about 15 years ago, and with Belzona 1341, I saw it 2 weeks ago, and it looked brand new within the pump casing. On the impeller, it had a couple touch-ups at the edges, but if anyone wants to see pictures of that, I have a pretty good example of the wear resistance that they have over time. Finally, I'm going to finish it off with pump bases. This can be, we have anything from concrete rebuild products to grouts to chalking for precise alignment, the metal rebuild to corrosion coatings for metal. So let's start out with concrete rebuild. This was an area that had sulfuric acid kind of dripping. So the concrete got beat up. We were able to rebuild the concrete and then put a corrosion resistant coating to protect the concrete from any sulfuric acid. We do have grouts as well, and chalking for precise alignment. Those are 2 products that we offer. And then the next picture I have here is just a metal base that was corroded. So we have your typical external coatings for external corrosion protection, but our coatings can also handle a lot of chemicals. So if you have any drips or anything like that, it's always a little more corrosive within the plants. They can handle a lot more than your typical external coating. that's about it. So